Hi there everyone, my name is Afan, and today I wanted to cover a simple proof, a very short proof of the derivative of y equals ln x. So we all know, or if you've done a calculus course, we've been associating ln x, or the derivative of ln x, so y equals ln x. So the derivative of y equals ln x, we know, y prime, I'll call it that, is y equals 1 over x. So this is just a fact that we are given, and we work through derivatives using this fact that we know. So today I just wanted to cover the proof for this. So why is it such that y equals ln x? Why is it such that the derivative of y equals ln x is actually 1 over x? So it's actually a very simple proof. There's two ways to prove this. You can use the first principle, so the actual derivative formula, or there's a simpler proof that uses a little bit of implicit differentiation. It's not anything hard. That's the one I'm going to show today. So let's go ahead and start the proof for this video. So again, our main goal is to get to 1 over x. So y equals ln x, right? So if you know what a natural logarithm is, you'll know that if I say e to the y equals x, that's the same thing as saying y equals ln x, right? Because natural logarithm is just basically a logarithm, but with base e. So this is just, log dx equals y. Anyways, so this is the same thing as that. So the natural logarithm is basically a logarithm with base e, so we just say ln for short. Okay, so now if you just take a look, so I have y equals ln x here. I restated that as e to the y equals x. So these are equivalent expressions, right? So what I'm going to do is I'm going to take the derivative of this, which is the same thing as this. So we're going to start doing that. So what I'm going to do is run my dy dx on e to the y, so that's this side, and I'm also going to run my derivative operator on this side, right? So whatever I do to one side, I do to the other side. Okay, so this should not be anything too difficult. I'm just running my derivative operator, right? Okay, so on this side I have, that equal sign is a little bit weird. Let me clear that up there. Okay, there we go. So on this side I have the derivative of x, which is very simple for us to do because we know what the derivative of x is. That's just 1, right? So I'm just going to do this side first. So this side, derivative of x, is 1. So we're done with that. This side is the side that requires a little bit of implicit differentiation. So if you know how that works, so this is pretty straightforward. If you don't know how implicit differentiation works, you can still get the basics of this. It's not too hard. Again, implicit differentiation is the chain rule, just a little bit more advanced. Okay, so I'm trying to find the derivative of e to the y. So to do this, first I need to take the derivative of the outside, and then I take the derivative of the inside. Basically the chain rule, right? I can go through du over dx. I can do all the formal stuff, but I think it's better if I just explain it. So the outside function here is e to the y, right? The inside function is just y itself. So if you know e to the x, right? When we take the derivative of e to the x, it's just e to the x. So in this case, the derivative of e to the y is simply e to the y. So I can write that, but I can also need to take the derivative of y, right? I also need to take the derivative of the inside function there, which is y. So when I take the derivative of the inside function, I can't. The derivative of y is just dy over dx, right? Change in y over change in x. So I have to multiply the two together, so dy over dx. Alright, so I took the derivative of the outside, which is e to the y, and then I took the derivative of the inside, which is y, and I don't know what that is, so I just say dy over dx. So I'm going to rewrite this as literally the same thing, so watch. I'm multiplying the two together. So this can, again, just be dy over dx equals multiplied by e to the y, because I have to multiply the inside, outside chain rule. Okay, so I basically have the same expression here and here, so that's pretty neat. Now, what am I trying to look for? I'm trying to look for the derivative, right? I'm trying to look for dy dx. I am trying to isolate this operator here. I want to know what the derivative is. So, simple algebra tells us that we can just divide both sides by e to the y, and that'll give us dy dx by itself. So if I divide both sides by e to the y, what I'll have is, if you don't mind, I'm just going to move over here. what I'll have is dy over dx on this side, right? I divide by e to the y, and then on the bottom I have e to the y, right? Because I divided both sides by e to the y, leaving dy dx by itself. Now if you notice, I have dy over dx, so I have the derivative is equal to 1 over e to the y. It doesn't look like 1 over x, does it? But notice, e to the y, we said, is equal to x. So I can just say the derivative, so it's a little bit messy, I apologize. Let me just do that. So dy over dx is equal to 1 over x. There we go. We showed that the derivative of ln x is equal to 1 over x, just by rewriting this statement as this, and then we just derived, or we took the derivative of both sides. This was 1, and this one was just a little bit of implicit differentiation. The outside function was e to the y, which is e to the y, and the inside function was y, so I don't know what that is, so I just wrote dy over dx, and I multiplied the two together, chain rule, and then I just, what did I do? Well, I just isolated dy over dx by dividing both sides by e to the y. So on this side I only had dy over dx, that's what I'm looking for, and here I have 1 over e to the y, and 1 over e to the y, well, e to the y is just x, so derivative is 1 over x. There we go, simple and pretty intuitive proof of the derivative of y equals ln x. Hopefully you enjoyed, and please subscribe if you want more videos like this.